Hi, I'm Jonathan Gruber, a security engineer at Imperva, and today I'm going to show you some of the new analytics capabilities that we've added to our infrastructure protection against DDoS. So previously you could see a lot of data in a very high granularity, 15 seconds, and you could zoom in, zoom out, see what type of traffic went through, what type of traffic was blocked. So you can see here the traffic that was passed, the traffic that was blocked, which data centers it went through, and so on. But we were often asked questions such as where do the traffic come from, what IP was targeted, and so on. So we've just released a new analytics capabilities to the system, and let me take you through it. So the first view that we can see is that we can see what are the target IPs. So you can see in percentage that this IP, for example, the first IP reached 100%. This means at the peak, at the highest, it represented 100% of the traffic. Okay, and at the highest, the second one represented 61% of the traffic. So it doesn't sum to 100 because it shows at the highest point. If you want to see an average of a certain period, just put an average and it sums to 100. Okay, so the first view only means that at a given point, it reached 100%. Now we can also view this in a graph pattern. So I can see IP by IP, what was the percentage and the weight of each of them at any given point, and I can zoom in, zoom out, and export to CSV. So it's extremely convenient. I can have this view for the volume of data of the packet per second. So you can see what was the targeted IPs. As well, you can see what are the source IPs, as you can see below. And this confirms that it is a DDoS, so distributed attack, as we can see that the highest IP, the IP that had the highest weight in the attack, only represented 6% of the traffic. So the IP itself has little meaning, except that we can know what networks it went through and what are the weak networks on the way. But it is a distributed attack and does not represent the IP of the attacker. And last, we can see what are the destination ports and source ports. So in our case, we can see that there were two targeted IPs, and that the service that was attacked is service 80, port 80 with the UDP traffic. So we can see that it represented 100% of the attack. So definitely we know that the targeted service was very likely a website or something sitting on port 80 on one of the top IPs that was represented above. We can see as well that as a source port we had 11,211, which corresponds to memcache type of attack. So we know the vector of the attacks and its weight into the total volume of the attack. So if we have a multi-vector attack, you can know the weight of each of the vectors, if it's a UDP, memcached, TCP flood, and so on. So last, infrastructure protection analytics gives us visibility of the packet size. And we can see that in our case, 85% of the packets have the maximum packet size of up to 1,500 bytes, which is a clear mark of an amplified attack. So few requests will generate a lot of packets, and the ratio of memcache attack that we have here is up to 1 to 50,000 ratio. So generating a lot of packets, which will be fragmented in the maximum size. So this is infrastructure DDoS protection analytics. It provides, as a summary, a lot of enhanced view that can be exported in CSVs, view as graphs or in tables, provide indication at any given point in a 15 seconds granularity of the target IPs, source IPs, targets, ports, source ports, for the pass traffic or block traffic. So it can also be extremely useful for data engineers, for network engineers to understand what's the pattern of the traffic in quiet times and attack times. Thank you very much.